Hello, discrete math fans. We're going to compose one-to-one functions and compose onto functions and see what happens. What happens if f mapping from x to y and g mapping from y to z are both one-to-one functions? What will happen with the composition? Will that be one-to-one? What if both f and g are onto? Will the composition be onto? And it turns out that the answer to both questions is yes, and we're going to walk through the proofs of these. So the first thing is we'll have a theorem that says that if f mapping from x to y and g mapping from y to z are both one-to-one functions, then g composed with f is one-to-one. Now, before we launch into the proof, I want to remind you what's the definition of one-to-one. We say that h mapping from x to z is one-to-one provided for every a and b that's in the domain if h of a is equal to h of b, then a equals b. So in our proof, what we'll do is we'll start with two arbitrary elements in x. That's going to be a and b, and we'll assume that h of a is equal to h of b. And our goal is going to be to prove that a is equal to b. Now in this case, in place of h, what we're really using is g circle f. All right, so here's our proof. Let's let a and b be elements of x, and we're going to assume that g circle f of a is equal to g circle f of b. Our goal now is to prove that a equals b. So g circle of f of a equals g circle f of b means g of f of a equals g of f of b. Since g is one-to-one, and the output to g is the same, then whatever went into g has to be the same. So that means f of a is equal to f of b. But we also know that f is one-to-one, so we can conclude now that a is equal to b. And that's the end of the proof. Therefore, g circle f is one-to-one. Remember, we wanted this as a conclusion. Okay, let's prove the same fact about onto functions. That is, that if f and g, so f mapping from x to y and g mapping from y to z, if those are both onto, then g circle f is onto. And again, I'd like to keep in mind the definition of onto. We're going to say that h mapping from x to z is onto provided for every c that's in the codomain, we can find an a in the domain so that h of a is equal to c. We're saying that there's an arrow that gets mapped to c. And we have to find out where that arrow comes from. So that means in our proof, we have to start with an arbitrary element c that's in the codomain and produce an element a in the domain so that h of a is equal to c. So in this case, instead of using h, we're really using g circle f. All right, we're ready for the proof. So we start with an arbitrary element in the codomain. So let c be an element of z. Since g is onto, there is an element b that's in y, so that g of b is equal to c. So remember that the function g will take elements in y and map them to z. Now since f is onto, now we can find an a in x so that f of a is equal to b. So now what's g circle f of a? Well, that's g of f of a, and that's going to be g of b, and that's equal to c. And so that proves now that g circle f is onto because we have produced an element a in x so that g circle f of a is equal to c. Okay, that's all for now.